everyone. We're here at KubeCon Europe 2025, this time around in London. My name is Miguel. I'm here with Lionel, and we are presenting a talk titled Uncharted Waters, Dynamic Resource Allocation for Networking. The plan here is for us to tell a little bit about dynamic resource allocation, what it is. It stands short notion is DRA, and especially what it means for the Kubernetes multi-network ecosystem. Let's first introduce ourselves.
So I'm Lionel. I'm working at Ericsson Software Technology. I'm mostly involved in the CNI community, in the multi-network community, and SIG-Network. And I'm also involved currently in DRA to have this multi-network happening with DRA.
Amazing. And I'm Miguel Duarte. I'm a software engineer working for Red Hat, particularly on the OpenShift virtualization networking team. I'm working on pretty much like pushing virtualization features into OpenShift's SDN. And let us walk through the agenda for this presentation. We will begin with the motivation and the problem statement for this. From there, we will explain and paint the multi-network landscape today in the Kubernetes ecosystem. And from there, we will perform like an introduction to dynamic resource allocation, especially what it means in the context of networking and multi-networking. From there, we will walk you through the most relevant Kubernetes enhancement proposals, specifically for multi-networking, and a very dedicated or very specific scheduling use case, and we will finalize with a live demo. So the problem, at least as we see it, is Kubernetes is opinionated. It is very opinionated, according to whom you ask. And by this, we mean that its networking model is extremely simple, and that might end up being like a double-edged sword, because what happens is every pod on your cluster will get exactly one interface, and every pod in your cluster will be interconnected and able to reach anybody else. So extremely simple, but if you don't want that, well, if you want micro-segmentation, you can put network policies on top to kind of define access and who gets access to what resource on what port and sort. But this thing is expensive, and it's expensive in two different ways. The first of which is computationally expensive, meaning that every time a pod gets created or you provision in a network policy, the system has to reconcile itself, recompute which IPs can access which IPs on which ports, and the whole shebang. It is also computationally expensive because somebody must write these policies, and somebody must maintain these policies and make sure that they make sense holistically in your system. Not everything is bad. One thing that is quite good about this is that you will, according to the Kubernetes networking model, there is no NAT on east-west traffic, and that thing, well, again, in our opinionated way, amazing. The motivation now for this is, but what if you don't want the default cluster network attachment? What do? You will, according to the networking model, you will have it. Another thing, and that is, that is very important, for instance, in the virtualization use cases. So again, I work for OpenShift virtualization, so its upstream is KubeVirt. What happens there is most of the people that we're seeing, they really do not even plumb the cluster default network into their virtual machines. They just attach like a secondary network and just use that. But still, their VMs which run on pods have this cluster default network attached to it. Another use case that you cannot realize with Kubernetes alone is, what if you want more than one interface? Let's say you are instantiating or you want to develop a VNF that requires more than one interface. Let's say a firewall, for instance. What do you do? So the fact that Kubernetes itself does not answer this does not mean that it's not possible. There are ways out of tree. So the Kubernetes network plumbing work group came forward with a de facto standard for multi-networking, which is implemented by multi-CNI. There are more CNIs that are implemented, but for the sake of this presentation, we will focus exclusively on multis, which implements that, but out of Kubernetes. So the way this works, or the way it would work in production, your cluster admin or your network admin would come up and would provision this network attachment definition CR that you see in your bottom left. And they would just provision like a JSON encoded, they would just provision the CNI configuration in each of these things. So a network attachment definition is essentially like a bag of holding for a CNI configuration for one network. And then your user, your pod owner, when they provision the pod, they would list in a dedicated annotation the list of additional attachments they want to have. And finally, you have multis configured in your system to be the cluster default network CNI. And what it will do is configure the cluster default network attachment, and it will issue, and it will plumb the additional attachments that you referred to in this particular annotation. This has some problems. First, it's very error prone and is very cumbersome. Why is that? Just look at the annotation and at the network attachment definition spec.conf attribute. It's pretty much like a JSON encoded string that you put there, and if you make any mistake, some things might happen. First of which, it might just flat out error your pod because you have put like invalid JSON, so it cannot parse it, so your pod will not start. Worse than that is, let's say that you are putting like the wrong attribute because you misread your documentation, for instance. Well, for instance, this happened to me a couple of times. Like, we have an attribute called VLAN ID, and if you forget that it's VLAN ID and you put there VLAN, well, it will do nothing and will connect your pod to the default VLAN instead of the VLAN that you want it to be connected to, which it will be extremely hard to debug. So, to address these shortcomings, there came forward like a group called multi-network inside, well, a subgroup of the SIG network focused in trying to bring multi-network into the Kubernetes tree. And this happened over this Kubernetes enhancement proposal, 3698. And the idea is mostly to translate from this network attachment definition, create something called the pod network in which you would define your provider. So you'd have something running your cluster that would look, anytime a pod gets scheduled, it would see that, well, this is requesting additional attachments for this particular network name. So in the bottom right corner, you see what would be the equivalent. It's a provider which does different things. And on the upper right corner, you have a pod. This pod, the most relevant thing here is it has a networks array in which you define the attachments, but in a, let's say, a typed way, which makes it simpler for you since you no longer have to use this JSON encoded string. By using it, a lot of things could go wrong. So, thing is, the feedback the community got from SIG-Network was essentially that changing the pod object specification is taking it like way too far. You need to come up with a way to, you need to come up with a Kubernetes native way of requesting a generic resource, and in your use case, that happens to be a network interface. If you do that, we're good. Let's say the feedback was the use case is relevant, it makes sense, but like, please do not touch the pod object specification. That's taking it a little bit too far. And that's the first thing we want to focus on. We need to come up with a Kubernetes native way of requesting a generic resource, which happens to be a networking interface. The second thing which is relevant to DRA, or to the upcoming DRA presentation that Lionel will walk us through, is the device plugin. The device plugin allows you to mount a physical device on your node into your workloads. It's available since Kubernetes 1.8. It was an alpha there, and its resource model is extremely simple. What I mean by this is that your pods will have can request this, for instance, this vendor.com/device equals X. And by extremely simple, I mean that this X must be an integer. So when requesting things, you can request, let's say, I want 5 of those, I want 1 of those, I want 1,000 of those. But this means that you have absolutely no way of having a shared device. And this is the shortcoming, or the biggest shortcoming we see right now in the device plugins. There is no way for you to share a device across different pods.
So, as Miguel mentioned, the CAP 3698 for multi-network has not been merged. It didn't get in Kubernetes. So the work around this initiative hasn't really stopped. In fact, it's already continuing and starting to get implementation within Kubernetes. And instead of having one group, it's spread over multiple different communities. What I mean by that is, for example, the network configuration is going through the CNI and other underlying APIs, such as CRI or NRI. The services are going through Gateway API. Multi-network group is still existing and still working on a pod network API, so the user-facing API that was proposed in the original CAP. And the last one, that is the most important, and it's what Miguel was mentioning, is to attach the pod to the network, so to have a network attachment, and this goes through DRA. So what is DRA? DRA is a new feature within Kubernetes that is currently in V1 Beta 1 in 1.32, will be in V1 Beta 2 in 1.33, and is aiming for GA in 1.34. So this feature, DRA, allows us to, or allows users to request resources for the pods and the containers. So the resources will be available on the node. The pod will request them using some API, and then so it will request them using some characteristic, and then the Kubernetes or the DRA feature will schedule the pod based on this requirement, configure the resource on the pod. So what we are seeing here in this picture is GPUs. So GPU is one type of the resource. It's used mainly for AI/ML use cases, but the resource, in fact, can be anything. It can be an FPGA, it can be compute resources, it can be volume, it can also be network interfaces. We can consider network interfaces as a type of resources that we can request, again, with some specific characteristics and node requirements. And each node, in that case, will have different network interfaces, will have different characteristics, as I said, and then the pod can request them, can create network interfaces based on these interfaces, so use some a partition of these network interfaces, but it can also be the full device and claim the full device. So if we do that in that way, using DRA, we consider a network interface has a resource, has a device, then we can attach the pods to the secondary networks. So how does it work behind? The first parts for DRA would be the scheduling. In DRA, we have this object called the resource slice, that lists what is available in the nodes. So we can list all the kernel interfaces. We can list the physical function, the network virtual function. So the pod will request this device or device on top of this device by using some specific characteristic, and then the scheduler will do his job to schedule the pod where this resources, all the resources that the pod requested. The scheduler will find a node where all these resources will be available. So this enables, for example, a non-uniform cluster in a more native way. As Miguel was mentioning before, we have a device plugin together with Multus, but complex use cases are not yet available. One of the things I'd like to mention is this CAP 5075 that is run by Peng from IBM Research, and that allows user to claim virtual devices on top of existing node resources. So, for example, we can claim a dedicated or have a dedicated bandwidth of a Mac VLAN on top of an ETH or on top of the network interface. So in this example on the slides, we have a Net1 interface that is claiming 7 gig of 10 gig node interface ETH1. And this is one of the examples, but there is a lot of use cases behind 5075. The second part for DRA is the network configuration, so configuring the device, configuring the network interface. For that, we have a new API in Containerd and other container runtime that is called Node Resource Interface that allows us to hook into pod and container lifecycle events, so we can detect when the pod is being created, and we can do some action at that time. So at that time, when the pod is being created, we can get the network requirement of this pod, call or create this network interfaces based on this requirement. So it can be done, for example, via CNI, or it can be done with anything. It's just up to the NRI plugin or the DRA driver to do that, to create the network interfaces. And the last part is to set the status of these network interfaces. For the status, we have this CAP 4817 that has been merged since 1.32. It's in alpha since 1.32 and will be in beta in 1.33. So it allows the DRA driver to report the status of this device and this network interfaces that has been configured on the pod. So what can be reported? It can be the IP addresses, it can be the MAC addresses, the interface name, it can be arbitrary data, for example, the CNI config or the CNI result. It can be also the conditions. So let's say that you have a pod that is ready. We can have a network interfaces that is dedicated for some specific traffic that is not ready. We can have a different level of readiness for the pod and have the readiness for each of the network interfaces of this pod. So now we no longer have only the pod IPs in the status. We also have this a status in the resource claim that indicates what are the IPs of the pods. For me, the two main reasons to have the status is the first one is the troubleshooting. So we can know with this readiness why the network interface is no longer ready, or why it has not been configured correctly or could not be configured. And the second reason is the network services. So if we have the IP addresses available in the API like this, we can fetch all the IP addresses and then, for example, load balance traffic over this secondary IP addresses. Now let's have a demo of this. So we will run a simple demo that will run two nodes, Kubernetes nodes. The first working node has two network interfaces. It has ETH1 and ETH0. The second one has only ETH0. And we will schedule 15 pods that will request a MAC VLAN interface based on this ETH1. So we will verify the network interface has been created, and we'll verify what is the status. So I hope you can see correctly. Let's check what we have in the cluster. So we have this CNI DRA driver here, that is a DRA driver that is made for networking and that is configuring the network interfaces using CNI. So this is the only custom components in Kubernetes. Otherwise, it's just normal Kubernetes without any other modification. So let's verify now the nodes. We have the kind worker node with ETH0 and ETH1, and we have ETH0 on the worker 2 only. And we have only two worker nodes, like this. The control plane, we are not really looking into this. I would like also to share or to show the resource slice that is listing the devices that are available in the pods. So this is a DRA object. So we have 2 resource slices, one for each worker node. Oops. So we can see ETH0 and ETH1. So we have 2 interfaces, as demonstrated previously with IPA. And for the other worker, we have only ETH0. So these network interfaces are exposed in the resource slice. So what we will do now is to deploy the 15 replicas that will request MAC VLAN interface based on this ETH1. So I applied a resource claim template and a deployment. So let's see the deployment first. Get deployment, and the deployment is called demo application. So this deployment is just a normal pods running Alpine without doing anything. It's just for the demo. But the interesting part is that it is pointing on the resource claim. Yeah, you can see it. It is pointing to the resource claim MAC VLAN or to the resource claim template MAC VLAN ETH1 attachment. So this MAC VLAN ETH1 attachment is contains the CNI config and every elements to configure the MAC VLAN interface based on ETH0. So let's see what we have in it. ETH1 attachment. Oops.
You're listing resource slices.
Oh yeah, thanks. Resource claim template. Yeah, thanks. And then in this resource claim template, we have the CNI config, the full CNI config in YAML format in that case, compared to Multus that was storing the CNI config in a JSON format, as Miguel showed previously, and it contains a resource that requests the ETH1 to be available where the node will, where the pod will be scheduled. So the 15 pods has been scheduled, and they have been all scheduled on the kind worker only, because ETH1 is available only there. And then if we check the resource claim, 15 resource claim has been created. So one for each pod that are part of this deployment. So let's check the resource claim, and we will see the status and what has been configured in the pod. So in this pod, we get an interface called net1 here that has this IP address 10.10.1.11/24 and this MAC address 76.4c17. So let's verify this in the pod directly. So this resource claim has been created for this pod that we're seeing in the result for field. So if we check using IP commands, what has been created, we can see that the network interface net1 is existing, 10.10.1.11/24, with the MAC address that has been stored in the resource claim dedicated for this pod. And we have now the pod attached to the secondary networks using CNI. So in the same way as Multus was doing, just in a native way now using DRA. So if that was everything I had for the demo. And if you want to get involved in this work and get have more progress within the community, There is 4 communities that I would recommend. The first one is the CNI community, where we are talking mostly about CNI 2.0 and how to make CNI more Kubernetes aware, especially about the problems that Miguel mentioned and the scheduling parts. The second meeting I would recommend is the working group device management that is talking about DRA, and it is a grouping of multiple SIGs in Kubernetes, for example, SIG-Network, SIG scheduling, SIG node, etc. The third one is multi-network that is working on this API, and then it's following every single thing that is related to the original cap that got rejected. And the last community I would recommend is the plumbing group that is running Multus and many other cool projects like SRV device plugin operator, and where we are also talking about multi-networking. So as a conclusion for this work, so the DRA allows us to request, or allows users to request any kind of data, and the network interfaces can be the DRA allows the users to request any kind of resources for the pods, and we can consider, as we have seen here in the demo, that the network interface can be a resource or a device. And one of the upcoming features that will appear at some point is this consumable capacity that will enable this kind of use case. So we can claim some or create virtual devices and claim parts of the node resources. So I would like also to thank you for
2 minutes.
Okay. Yeah, I would like to thank you for your attention, and if you have any question, please come here and then, or come after, and then we'll be happy to answer them.
Yeah, sure. If you can also like provide us some feedback to our talk, just scan this and tell us good, bad, meh, anything goes. If you want to make some questions now, I think there's a microphone somewhere there in the middle. You'd have to go there. Sorry. And if not, I think we're done.
Yeah.
Thank you.
Thank you.